Yeah, Unit 1, forces and motion. First of all, tell me, what do you know about it? Forces and motion.
Forces and motion, I know like there's like three laws of Newton, like there's three laws of Newton's in forces and motion.
Okay.
Like those three laws are related to like motion and all. There's this, you can calculate motion, forces, and then there's like a lot of different stuff. You can calculate acceleration, there's distance, time, there's graphs.
Okay, let's start with motion. What remember I taught you in the now I'm starting to recollect what I taught you in the demo class. Right? Remember in the demo class I taught you about motion, right? Now what is motion? Motion is a relative term.
What do you mean by relative term?
A body
Like,
can appear to be moving for one person. At the same time, it is at rest for another person. For example, right now, do you see me moving?
yes,
Where? Where am I moving? I'm at rest, no?
you're doing this.
Oh, that's fine. Okay, now do you see me moving?
No.
So I'm not changing my position with respect to my surroundings. So I'm at rest. But if you go on the moon and if you see me, you will say, ma'am is rotating and revolving round the sun along with the earth. Am I right?
Yes.
So, it's a perspective. Okay. So at one particular time, okay, I may be at rest. But at the same time, for some other person, maybe someone who is watching me from the moon, I may be rotating and revolving around the sun. So
Oh,
I'm in
okay.
motion. So that's
Okay,
what.
okay.
Okay, so wait, just give me a moment. I think I'll start from the starting. I'll get to know what you actually know about, right? So I have
Okay.
my PowerPoints.
Wow. Do you like teach A-level students?
What?
Have you like taught or teach A-level students?
Yeah, 11th and 12th. Yes.
No, like year GCSE ones?
No, GCSE I have not stopped. I have not.
Oh, okay. Do you have any year 10 GCSEs?
Yes, I do have.
Oh. I'll be in
Okay.
year 10 now, so I'll be a first year 11 student.
Yes, definitely.
September.
So now, listen. Ah, wait. Your GCSE, right? So you give your board exams in year 11, right?
Mm-hmm.
Am I right? So after September, you will be in year 11, right?
Yes.
So I have a year 11 student.
Okay.
Okay, so right now she's in year 10. She's on a vacation for 1 month. We have
I
finished
have two
almost all the
months.
portion. But we have finished almost all the portion. And what are you doing? Why these balloons are rising
I
up?
don't know. I did two and then the balloons came. There's something
Oh,
about Zoom.
oh, okay. So what are you observing right now? You can observe, you can observe so many things are in motion, right? Yeah.
Yes.
Okay. So what they are trying to say is, let us learn first what is motion and let's go to laws of motion. Now, whatever I'm going to teach you today is going to be very, very important, right? First of all,
Mm-hmm.
what do you mean by motion? As I told you, motion is a relative term. For example, this is an observer standing over here. This is Yash, and this is the car. And this car is a ghost car because there is no driver in it. And this car is moving. So this car changed its position with respect to the surroundings, right?
Yes.
So as per the observer, the car was in motion.
So it's technically it's in relative what?
Relative term.
Oh,
Because this car was changing its position with respect. For example, for me, if I'm changing my position with respect to the surroundings, immediate surrounding,
mhm.
I am in motion,
Yep.
right? So a body is said to be in motion when it is changing its position with respect to the surroundings, right? For example, the hands of the clock, they are changing their position with respect to its surrounding. They are in motion. The water of the waterfall, wow, it is changing its position with respect to the surroundings. It's in motion. And when you talk about Earth, yes, changing its position with respect to the surrounding, that is the space
Uh-huh.
and the other planets, right? So Earth is also in motion,
So
right?
technically,
Now,
Earth is like we see Earth as still, but then it forms other, like the solar system is moving.
exactly. We all are moving because we are on Earth. Even if I'm
Yeah,
sitting,
yeah.
I'm moving actually. But as I told you, it's a relative perspective. For you, I am at rest. Maybe for some alien, I am rotating and revolving around the Earth. Now, body at rest. What does a body at rest mean? When the body does not change its position with respect to its surroundings. For example, this car, okay, it is halted. So this car is at rest. It is not changing its position with respect to the immediate surroundings, right? Then we come to, now this person is watching the Statue of Liberty.
Yes.
So he will say the Statue of Liberty is at rest. At the
Yep.
same time, there is an alien on the moon and he is watching it. What he will say is the Statue of
It's
Liberty at
moving.
rest. It
It's
is
moving.
rotating and it is revolving also. Am I right?
Yep.
So that's what I
Yes.
said. Motion is relative. It depends upon the observer. Clear? So a
Yes.
body can be moving for one observer and at the same time, it can be at rest for another observer. Clear? Yeah. So right now, no need to write all these things. Just understand them. Now, what you need to write and actually understand precisely for your subject, for your chapter, is uniform and non-uniform motion. Now, whenever you talk about any motion, see in your syllabus, we only have single dimension motion.
What
That
is
is
a single?
motion in one dimension. For example, a body moving in a straight line. This is a path and a body is moving like this. This is one dimension motion. If I say a car taking a turn on a curved road, or if I throw a ball in air and it follows the parabolic path like this, right? This is a two-dimensional motion. And what is three dimension? Bird flying in
Oh,
air. Bird
how?
flying in air is a three because it is using all the three dimensions. You don't
What do
know
you mean
next
all
where it
three?
will go. X, Y, and Z
Oh.
axis,
But
right?
like, can't a ball bounce and then go up again?
That's a
Isn't that
different
the?
thing. That's a different thing. I'm talking about this motion, projectile motion,
Oh, okay.
right? So when you talk about motion in one dimension, see, right now your studies are restricted to one dimension motion. Clear? So motion is of two types. One, uniform motion and non-uniform motion. When you talk about one dimension motion, which is your scope of syllabus, there are two types of motion, uniform and non-uniform. In uniform motion, what is uniform?
Uniform was something is like steady. Is like
Yeah, uniform means steady. But which physical quantity is uniform? Yes, in the first lecture, I taught you about physical quantities and scalars and vectors, if you remember.
oh yeah, yeah, yeah.
Remember? I told
A
you,
little
whoever starts physics should know this. What are physical quantities?
physical quantities are like I don't know how to explain it.
Anything that can be measured.
Oh yeah, yeah, I remember
Anything
now.
that you can measure is a physical quantity.
Yeah.
Just give me a moment. Yeah. So anything that you can measure is a physical quantity. So in uniform motion, which physical quantity is uniform? What is uniform motion? Let's see.
One second.
Yeah, tell me. What are you doing?
I'm just gonna write that down. Yeah.
Wait,
Okay.
what is uniform motion? Yeah, it's a motion
The,
in which an object covers equal distances in equal intervals of time. This
oh,
type of
so
motion is called as uniform motion. So when I say equal distances in equal intervals of time, don't you think speed is equal to distance over time?
yeah.
So if time intervals are equal, Distances are equal. Don't you think speed is uniform here?
Yes.
Yes. So motion in which an object covers equal distances in equal intervals of time is called uniform motion. What is a non-uniform motion?